Hello everyone, I am here to present you and explain you some 2 marks and model multiple choice questions with answers and explanations for the subject signals and systems. I have covered topics like classifications of signals, continuous time and discrete time signal, periodic and aperiodic signal, deterministic and random signal. So the following content will be also useful for online preparation as well as government exams, which includes signals and systems as the subject. First question, what are the different types of signals? Signals are classified according to their characteristics. Let us see some of them. They are continuous time and discrete time signal, periodic and aperiodic, deterministic and random, energy and power signal. So in the following slides, I have clearly explained CT/DT, periodic, aperiodic, deterministic and random signals. And the next video, I will explain energy and power signal. It's related to 2 mark questions and MCQ questions. So if you write the signal, write an example. Explain in brief regarding continuous time signal. So continuous time signals are signals which are defined at all instants of time. They are also called as analog signals. They are denoted by x of t. So you write x of t sine 2 pi t as an example, and you can also draw a graphical representation of a signal. Okay. Discrete time signals are signals which are defined only at particular instance of time. So we should clearly know the difference between continuous time signal. They are defined at all instant of time or every instant of time, but these discrete time signals are defined only at particular instance of time. They are denoted by x of n. Example, log 6 pi n. So this is an example of discrete time signal. You can also draw a pictorial representation of a discrete time signal. They may also ask you the differences between continuous time signal and discrete time signal. You can write continuous time signals are denoted by x of t. Discrete time signals are denoted by x of n. Then the second point, continuous time signals are defined at all instants of time. Discrete time signals are defined only at particular instance of time. Okay, you can write third point as example x of t equal to sine 2 pi t. In discrete time signal, you can write example x of n is equal to log of or exponential of x of n, 6 pi n, any example. Okay. So continuous time signals are defined for every value of time or all values of time. MCQ questions. Discrete time signals are defined for particular instant of time. Discrete time signals are dash in time and dash in amplitude. They are discrete in time. In the time period, they are discrete, and they are continuous in amplitude. So what about continuous time signal? Continuous time signals are continuous in time and continuous in amplitude. So these 2 points can be added as the next difference between CT and DT signals. So in the CT signal, you may write continuous time signals are continuous both in time and amplitude. But in discrete time signals, they are discrete in time and continuous in amplitude. Explain in brief regarding deterministic signal. A signal which exhibits no uncertainty of its magnitude and phase at any given instant of time is called a deterministic signal. Example, sine wave, exponential signals. You can write any mathematical expression for that signal. You can also draw a graphical representation. So you can write mathematical expression as well as graphical representation. So in the other way we can say deterministic signal exhibits no uncertainty, okay, of its magnitude and phase. What about random signal? A random signal is characterized by uncertainty. At any given instant of time, we cannot predict the signal. Uncertainty means we cannot predict the signal. We cannot predict the shape of the signal. We cannot write the mathematical expression of the signal. So, random signal cannot be represented by any mathematical equation. Example, speech is a signal, right? Noise is also a signal, which are unpredictable, so they exhibit uncertainty, so they cannot be predicted. So those signals are called as random signals. You can draw this graphical representation as example. A deterministic signal has dash at any given instant of time. It has no uncertainty. A random signal has dash at any given instant of time. It exhibits uncertainty. Explain in brief regarding periodic and aperiodic signal. So first of all we will see what is periodic. It's example also. Okay, a signal is said to be periodic if it repeats at regular intervals of time. Example, sin omega naught t plus theta is periodic with the fundamental period t is equal to 2 pi by omega naught. I will clearly explain what is fundamental period, what is omega, what is t and all in the next following slides. A signal is said to be aperiodic if it does not repeat itself at regular interval of time. Okay, if you write an example for periodic signal, write along with the fundamental period. Okay, if you write an example for aperiodic signal, there will be no fundamental period since it is a aperiodic signal. The sum of two periodic signal is periodic only if the ratio of their respective periods t1 by t2 is a rational number. So what is a rational number? Ratio of two numbers is said to be a rational number. Derive an expression for a continuous time signal to be periodic. So a continuous time signal which is always denoted by x of t is called a periodic signal only if it satisfies the following condition. So what is the condition? X of t plus t equal to x of t for all t. So what is this small t and capital T denotes? Small t denotes time and capital T is a constant. So what is this constant will do in the expression? So the least value of t that satisfies the given condition is called the fundamental period of x of t. So this t is called as the fundamental period. So a signal is said to be aperiodic if the condition x of t equal to x of t plus t is not satisfied for a single value of t. So what is small t? It denotes time. What is capital T? It denotes fundamental period. The reciprocal of fundamental period is called the fundamental frequency. So frequency is denoted by f. F is equal to 1 by t. So what is f? F is fundamental frequency. What is t? Fundamental period. So there is another term called angular frequency. What is angular frequency? Angular frequency is nothing but omega. Omega is equal to 2 pi f. So what is f? F is 1 by t. So 2 pi into 1 by t will give you 2 pi by t. So omega is equal to 2 pi by t. From that expression we can write t is equal to 2 pi by omega. What is t? T is fundamental period. So fundamental period t is equal to 2 pi by omega. So the formula to calculate fundamental period is equal to t is equal to 2 pi by angular frequency. So what is angular frequency? 2 pi f. So in the similar way we can derive an expression for discrete time signal to be periodic. So discrete time signal is always denoted by x of n. So the condition for a discrete time signal to be periodic is x of n is equal to x of n plus n, or x of n plus n is equal to x of n. What is small n denotes? Small n denotes time, capital N is a constant. So that capital N is otherwise called as the fundamental period of x of n. A signal is said to be aperiodic if the condition x of n plus n is equal to x of n is not satisfied for even for a single value of n. So the condition for a discrete time signal to be periodic is x of n plus n is equal to x of n for all n. So in the similar way, the reciprocal of fundamental period capital N is called the fundamental frequency of f of n of x of n. So f is equal to 1 by n. Angular frequency omega is 2 pi f. So instead of f you substitute 1 by n, you will get 2 pi by n. So finally fundamental period n is equal to 2 pi by omega. Examine whether the given signal is periodic or not. X of n is equal to cos pi 30 n divided by 105. So first of all, this is a discrete time signal. So you write solution, compare the given expression with the general expression x of n is equal to cos of omega n, or in the other way you should first write what is omega. So what is omega? Omega is nothing but the coefficient of n. So what is coefficient of n? 30 pi by 105. Okay, 30 pi by 105 is the coefficient of n, that is said to be omega. Okay, so what is omega? Omega is equal to 2 pi f. Okay, so 2 pi f. So what is fundamental period? N is equal to 2 pi by omega. So instead of omega you write 30 pi divided by 105. Pi will get cancelled. 230 you will cancel and write 115. 105 divided by 15. So on the calculation you will get 35 by 3. So 35 by 3, is it a rational number? Yes, it is a rational number, because what is a rational number? Rational number is ratio of two numbers. Okay, so the fundamental period on calculation should be a rational number. So here the given signal is a periodic signal. X of t is equal to sine 24 pi t plus cos 36 pi t. Examine whether the given signal is periodic or not. So first of all, this is a continuous time signal, addition of two signals. Okay, so you can write, let us consider x of t equal to x1 of t plus x2 of t. We will calculate the fundamental period separately for x1 of t as well as x2 of t. So you can write the coefficient as omega 1. So what is the coefficient of omega 1 here? Omega 1 is equal to coefficient of t, right? So what is the coefficient of t here? 24 pi. Or otherwise you can compare it with the general expression x1 of t is equal to sine omega 1 t. If there is a confusion in comparing it with the general expression, you can simply write the coefficient of t as omega. Okay, is it clear? Am I very clear? Omega is nothing but, what is omega? Angular frequency. It is nothing but the coefficient of t in the given expression. If it is a discrete time signal, it is the coefficient of n. The second way to calculate omega is comparing it with the general equation. General equation x1 of t equal to, if it is sine means you write sine, if it is cos means you write cos. So sine omega 1t. So instead of omega 1, what is available here? 24 pi. So therefore, what is omega? 2 pi f1 equal to 24 pi, or f1. So you can cancel 2 and 24 into second multiplication table. You will get f1 equal to 12. Period of x1 of t is t1. So what is t1? Reciprocal of the fundamental frequency. So 1 by f1, that is equal to 1 by 12. So we have calculated the fundamental period for the first signal x1 of t. In the similar way, we can write the second signal x2 of t as cos 36 pi t and compare it with the general expression, or you can write the coefficient of t as omega 2. Omega 2 is equal to 36 pi. Therefore, 2 pi f2 equal to 36 pi. You can cancel it in the second multiplication table. You will get f2 is equal to 15. So, reciprocal of frequency will be the fundamental period. So, T2 is equal to 1 by 18. The ratio of 2 periods will be the final answer, that is equal to T1 by T2, 1 by 12 divided by 1 by 18. So, you will get 18 by 12. So, 18 by 12 on cancelling you will get 9 and here you will get 6. So, again if you cancel 9 you will get 3 and here you will get 2. So, 3 by 2. Since T1 by T2 is a rational number. So, what is a rational number? 3 is an integer, 2 is an integer. Ratio of two numbers is called as the rational number. The given signal x of t is periodic. Examine whether the given signal is periodic or not. Again, you have given two signals. X of t equal to cos 4t plus sin root 5t. So, you can write x1 of t and x2 of t. Calculate omega 1. Calculate the fundamental period of x1 of t. That is t1 equal to 1 by f1. So, what is f1 here? 2 by pi. So, what is t1? Pi by 2. Then x2 of t as sin root 5t. Compare it with the general expression, or you can write the coefficient of t as omega. Omega 2 is equal to root 5. So, what is omega 2 pi f2 is equal to root 5, or f2 is equal to root 5 by 2 pi. What is period? Period is nothing but the reciprocal of what? Fundamental frequency. T2 is equal to 1 by f2, or directly you can write 2 pi by omega. In place of omega you can write what is omega to root 5. Directly you will get 2 pi divided by root 5. So, the ratio of two periods T1 by T2 is equal to pi 2 divided by 2 pi by 5. So, you can cancel pi, but you cannot cancel 2. Root 5 will go in the numerator and 2 will get 4. So, in the numerator you have root 5 and in the denominator you have 4. So, root 5 is not an integer. Root 5 is not an integer. So, it is not a rational number. Rational number means numerator and denominator you should have integers as numbers. Okay. So, the given T1 by T2 on calculation we have got as an irrational number, or it is not a rational number. Therefore, the given signal is aperiodic. Examine whether the given signal is periodic or not. X of n equal to cos of n by 6, cos of n pi by 6. Here, the two signals are in the product form. So, given x of n equal to cos of n by 6, cos of n pi by 6. So, let us consider x of n is equal to x1 of n, x2 of n. So, what is x1 of n? Cos of n by 6. So, compare it with the general expression. You will get omega. So, what is omega? 2 pi f1. f1 is 1 by 6. So, f1 equal to 1 by 12 pi. So, what is the fundamental period? Reciprocal of fundamental frequency. So, since this is a discrete time signal, you should write n1. So, n1 equal to 12 pi. What about the second expression? x2 of n equal to cos of n pi by 6. Compare it with the general expression, or you can write omega 2 is equal to pi by 6. So, calculate period of x2 of n as n2. n2 is equal to 1 by f2, which is 12. So, ratio of two periods is said to be n1 by n2, which is 12 pi. What is n1? n1 is 12 pi here. What is n2? n2 is just 12. So, 12 pi divided by 12 will get cancelled. You will get pi as the answer. So, pi by 1, in the other way you can write pi by 1. So, pi by 1 is surely a irrational number. n1 by n2 is not a rational number because they are not a ratio of two integers. Therefore, the given signal x of n is aperiodic. Examine whether the given signal is periodic. Okay, x of n equal to cos of pi by 6 plus 0.3 n. So we should be worrying about only the coefficient of n. We should not worry about the pi by 6 here. Okay, so in order to confuse you, they will give like this expressions also. So what is the coefficient of n here? It is 0.3. So omega is nothing but 0.3. So 2 pi f is equal to 0.3. F is equal to 0.3 by 2 pi, or multiply in order to make 0.3 into 10 divided by 2 into 10, you will get 3 by 20 pi. So what is the period of x of n? Since this is a discrete time signal, we should denote it by capital N. N is the reciprocal of frequency, which is equal to 1 by f. So 1 by f is equal to 20 pi divided by 3. Therefore the given signal x of n is a periodic. So therefore the given signal x of n is a periodic. So another discrete time signal given here, it is also an aperiodic signal. If x of n is equal to u of n, so what is u of n? Check whether the given signal u of n is periodic or not. So u of n is a unit step signal. So what about unit step signal? Unit step signal will be like this for the entire time period, right? So elementary signals are said to be the aperiodic signals. Okay, just an information. So this is about the signals. So you can post your comments regarding the video. If you have any doubts, you can post it. Okay, so keep supporting me and this channel and subscribe for more videos. And in the next video, I will cover energy and power signal as a topic, both 2 marks and MCQ questions. Thank you.